Good day everyone, and welcome back to class. This is another training section of data analysis, and I'm still your instructor, Olayemi Adewale. I've taught us how we can use the graph menu to plot graph like bar chart, pie charts, histogram and others, and a scatter diagram. But at the same time, when you are running regression analysis, there is always you plot a graph. And how do we plot that graph? Even that graph is called a scatter diagram as well. How do we now plot our graph in SPSS with regression analysis method? Here we have today. Let's go. Now these are variables and data I've entered, and now I want to plot regression graph. Okay, now before I move to that regression graph, let's just familiarize ourselves with what we taught before. I said graph. This is a graph, and under this graph we have three menu or three ways how we can plot a graph. We have chart builder, that's what I've taught before. We have a graph board templates chooser, and we have legacy dialogues. Under the legacy dialog we have this. We have bar charts, we have 3D bar charts, we have line graph, area graph, pie charts, high-low graph, box plot graph, error bar graph, population pyramid graph, scatter dot graph, histogram, interactive. Under interactive we have another sub graph that we can do from interactive. We have bar, that is bar chart, we have dot graph, we have line graph, we have remain graph, we have dot line graph, area graph, pie chart. And under pie chart, now here we have three types of pie charts we can do. We have simple, we have staked, and we have plotted. And we have another one here is box plot graph, like the one we have upward before. We have error bar graph, histogram, and scatter plot graph. Okay, that's using the graph menu. But I want us to do one before we now go back to the regression graph. Okay, which one do you want us to do under this legacy dialogues? Let me show pie chart. Now I say, is this, now look at it. Under this panel it said summary of the group of the cases, summaries of the separate variable, value of individual. Now I want the summary of each variable I put here. I want the variable, I want the summary. Not that you should put it in the filter, that will be summa numbers. On there I click summaries, I say define. The dialog box will come where I will put in my data. Now define slide by what? Now I would like to define it by years. I put it here. The row, maybe I want to do for export, import, degree of openness. I need a real exchange rate and real interest rate. I put it now, and once I've done, now here we have two options. I have title button and I have option button. Now if I want title, maybe now the line 1, which title do I want? Let's say pie chart showing GDP with other variables. I click continue. The title will appear. Now in my slide, now is it the number or the percentage I want to appear? If I click percentage, no problem. If you can click, you can select any of these three. You can use the number of cases, percentage of cases, and sum of the cases. Now I decided to use percentage of cases. Now we click OK. Okay, our graph is coming. See, this are graph, this are graph from that place, this are graph, because there are many this are graph. Look at the table here showing the color, this are graph, this are graph. Now let me go further again, legacy, and put patch summary of define. Okay, what do I want? The slide that I want. Okay, 2 3, I want only these 3. You say okay. Now let's check our results. Look at it now. Look at the results. The gray one, the blue one is talking about import. This one is talking about export. While the green here is talking about import. Look at the graph. This is a pie chart. But that one is complex. I didn't put some the summary of individual as it now. The group summary now, that's one is giving now. The whole column here is representing that export. This one is representing the import. The while this blue one is representing the GDP. Can you see now? All right, that's how we can use our graph menu to plot graph, any type of graph. But now when you're talking about regression graph or regression curve, we have to go to regression and run the graph right away. Okay, let's go back to regression. Let's go back to regression and our data. See now, we see our data there. I'm still using the same data. You go to analyze, you come back to regression, linear regression, you click on it. Okay, our dependent variable that depend is our GDP. Okay, the import and exports is independent. Reinterest rate is independent. Okay, now after this you come back to these 4 buttons. I have statistics, I have plots, I have save, I have auction. Majorly you have to deal with statistics. Now here, look at it. I have estimate under regression coefficient. Regression coefficient, you click coefficients interval, which is giving us the probability value of 5%. The model fit. Don't want discrete analysis as main media mode. Yes, if you don't want, you non-click it. Then you come to this place, case wise diagnostic. You click on it because that one and those being worst thing is a residual statistic that we need, and that residual statistics and those wabi is telling us that our highest value is 3. They range from that 1 to 3. Now anything less than 1, it means that even that the swabbing is telling us that anything less than 1, the analysis or the result is not good. It's not good. It's not statistically okay. Now, okay. Now you come back to your plots. You click on continue. You come back to your plots. You click on it. Now look at this place. We have dependent. We have said predicted, said residue, D residue, adjunct debt, and residue, and standard deviation residue. Now said residue, this one, this said predicted, this one, you click on it and that will go to x axis, and said residue, you come to, you click on it, said residue will come to y axis. You see it now. Then under standardized residual plot, you click on histogram and normal probability plot. That is where we are going. Normal probability curve, you click on it, you say continue. Now once you have done that, all this was just option. Now that's probability. If I know you've taken under the statistics, we have 95%, and between that 95 now we have a 0.5 95%, you know it is 5%. When you convert that one to 100, that's 0.5 significant level, and we say okay. And see there's nothing valid, say exclude cases litwise, say continue. Then you come back to this place, you say okay, and let's wait for a result. These are results. Now we have, I don't need to explain this table because I've done that one before, because we click on descriptive statistics. That is why we have this descriptive statistics. We have mean, standard deviation, and the number. Okay, and that is the mean for GDP, the mean for imports, exports, and interest rate. The standard deviation, this is the first one we have here. The second one that we have now is correlation. Then how all the variables I put, are they correlating? Now look at this one. No, GDP and GDP, since they have the same value, that's why it's 1. GDP with imports, we have this, that's 88, and GDP and exports, we have 98%, and real interest rate and GDP, we have 0. This one is 0.085, 0.928, and 0.180. That's the one. And this one to imports with GDP, import with exports, import with interest rate, that's the value you have here. And these are the significant level that we have. The import is significant based on this value that we have here, and this n, that is the number of observation of the variable that we enter. Okay, that's second table. Then the third table is talking about variable entered and removed, and what the method we use is variable entered. That's the method, variable enter. Okay, now the model summary that we have here, and this regression, and this regression square is a determinant of our correlation analysis, okay, that we have at the top. And adjusted regression square is there. I've explained that one in our previous class. Now this model summary, the A and B is combined in this place. The A and B is combined in this place. This regression analysis result here. All right. Now let's move down. The fourth table is talking about ANOVA. And the meaning of ANOVA is what? Analysis of variance. And that's our regression, is degree of freedom, and residual, and these are F statistics. And from this place now we can see that our significant level is 0.00, which is less than 0.05 that we said above. 0.05 from 95% of probability coefficient. Therefore, since our result is showing that is 0.005, is telling us that is statistically significant. Alright, then the coefficient value that we have here, this is it here. That one is talking about our A and B, which is we have unstandardized coefficient and standardized coefficient. The standardized coefficient, the A and B, is combined under this B, like I said, is combined under this constant. The constant, which is A, is constant A. That A and B are combined here. That's why you don't need to bother yourself about standardized coefficient. The major work is under this unstandardized coefficient. Therefore, by the time we write out our equation, it's going to be 922.897 equals to 8.289 times into imports minus, because this is minus 0.506 into exports minus, this is also minus 41.487 into real interest rate. That's the variable that you, and these are the what are the t-test analysis from this variable, and these are significant level. And from this significant level now we can see that this import is the one that has 0.000. The other two variables, apart from constant, this one has a 0.361, while this one has a 0.729. It's so that it's only imports that is significantly okay from this analysis. These are case-wise diagnostic, and residual statistics. And residual statistics is talking about mean, median, the one we've done, the mean, standard deviation, the mean, the minimum and maximum of the variable predicted residual and standard predicted value and standard residual value, and our dependent variable is still our GDP. Okay, look at the histogram that I have. Look at the histogram I click. Look at dependent variable GDP. Now under it, now the combined efforts now say regression standardized residue must be here. Regression standardized residue. Look at our graph. It is not really normal, because if it is normal, the gap here, we should not have a gap here. Look at this gap now. We should go in that direction and move that, and all the variable use must be at the center, and this mean, the standard deviation of this, and the number of observation. This is it now. Now the normal PP plot graph is probability plot graph of regression standard residue. Okay, let's see. You see it now. Look at there. Now this one now is positive, but all the variables supposed to be on this line. Look at it now. Look at it now. Okay, let's do something. Let's come back to this place and put this line and put this. Okay, we have that now. And if you look at our y, look at our custom equation. Y equals to 1 s times plus 0. Okay, and say okay. Let's now move and see now. This is it now. Look at the line. Look at it now. It does not follow this. All the variable that I have is not in line with this plot graph. This observed cumulative probability and a dependent and expected cumulative probability. This is it now. And once all this variable that I use now, they are not on this line. Actually, though the line shows that it is directing to positive side, but they are not. They are scattered. That's what we call a scatter diagram. Scatter plots. See, they are scattered, and if they are scattered now, for us to get a good fit result, they must be on this line. Majority of them must be on this line on this line, or they come together. But now that majority of them are not in that one, it is not good fit. There is a challenge in that GDP with now. And let's look at the scatter plot of. Now look at our scatter plot. Let's regression standardized predicted value. Predicted value. Let's see. Let's have predicted value as well. Let's see. Okay. Let's say okay. Okay, now predicted value. This predicted value. Okay, if we check this one, because we've put the line will show that this is a predicted value that we should have. Compare with this one. Look at it now. This was supposed to have. Look at this one. Compare it must come like this, but compare with the one that we have here. Look at how we have our variable, but how we have our variable not online. And this is what we call regression curve or scatter plot for regression analysis. These are taken. Thank you. God bless you.